So here's some notes for my advanced students on vectors. So a vector is a mathematical quantity that has size or magnitude and direction. So for example, here's a movement from one place to another place, from here to here. Now it doesn't have to be fixed between those places, but it's any movement that is in that direction and that distance. So you can define it in terms of a starting point and an end point. So here's the point A, here's the point B. So the vector AB is any movement that is equivalent in size and distance to moving from A to B. So it could be up here, and then we move that same size and distance, distance and direction, I meant distance and direction. We can define it in terms of how many across and how many up or down. So to get from A to B, you go 10 across and 7 down. 10 minus 7. And you can also define it in terms of a single letter that you label the vector with. So you've got three possibilities: a horizontal and a vertical component, a starting point and an end point with an arrow over the top to indicate direction, and then a single letter with a squiggly thing over the top. So for example, a boat is steering a course that takes it in a direction represented by the vector 2, 5 over a given time period. So that could be a direction that's equivalent to going 2 units to the right or east, and 5 units upwards, which would be 5 units north, over a given time period, every hour, for example, that could be. However, a storm pushes it off course by 7/3. So over the same time period, the storm is in the distance and direction that's equivalent to 7 to the right or to the east and 3 upwards or 3 to the north. Where does it end up in relation to its starting point? So there's the intended course of the boat, 2 along, 5 up. There's the effect of the wind, 7 along and 3 up. So the boat actually ends up going a combination of the two, which is 9 across and 8 up. And you can get that 9, 8 just from adding the intended course of the boat that I've labelled red here and the effect of the wind that I've labelled green here. So 2 plus 7 gives you the 9, 5 plus 3 equals 8. Now you might notice there that I've added the top and I've added the bottom of each of those things. So it's not working like fractions. It's not the whole having to make the bottom numbers the same situation that you have with fractions. These look like fractions in the sense that you've got a number on top of another number, but they're not fractions. And they don't work the same way as fractions. So beware of that. Vectors are not fractions. A fraction represents one number out of another. A vector represents the horizontal movement and the vertical movement as separate components. You don't draw lines between the numbers on vectors like you do in fractions. And to add vectors, you just go top plus top, bottom plus bottom. So there's no question of having to make them out of the same denominator. The bottom numbers aren't denominators, they're just vertical components of the movement. So there are some book exercises and indeed some MyIMath exercises.